Okay, so we just saw an example of making a compound statement within the data frame context. But I just want to examine, and in fact, we did a compound statement for a conjunction, or for the AND operator, AND operator, which is the ampersand in R. But we just want to examine that more abstractly or formally. Forget about R for a minute and just talk about the AND operator. So, as I said, you already know this, and it's not new, but this is the way that this is usually explained, so I wanted to present it to you so that you would be familiar with it. So let's suppose we had this first statement. Tokyo is in Japan, which is true, and 1 plus 1 equals 2, which is also true. So so both of these are true, so if I say this and this, that's a true statement. However, suppose I said Tokyo is in Japan, but 1 plus 1 equals 1. This is true, but this is not true. So if I made this conjunction, you would say, no, that's not true. The entire compound statement is not true because it asserts that both are true when they're not both true. And how about if I said Tokyo is in China and 1 plus 1 equals 2? Well, this part is true, but this part is not true. If I made the assertion that both are true, that is, if I made the AND statement, you would again say, no, of course that's not true. And the same thing here, Tokyo is in China, this is false, and this one is also false. Then of course you would say that the compound statement is not true. So what have we discovered? We've discovered that the only time that the compound statement is true is when both parts are true. So that's what this so-called truth table for the AND operator, or the conjunction, says. So we talk about each part. So P and Q, so there are two parts, just like here and here. There are two statements, two simple statements, which we put together into a compound statement. This is a compound statement here. But we look at each part to see whether each part is true or not. So, like the first one is true and the second one is true. That would be here. The first one is true. P is the first one, is true. And Q, the second one, is also true. In that case, then the compound statement is true. However, in the case where the first part is true but the second part is false, then the compound statement is not true. We said the second one wasn't true. And in the case where the first one is true and the second one is false, then this is false. And in the case when they're both false, then again, of course this is false. So if you have two statements that make up a compound statement, so two individuals, P and Q, two of them, and each one can be either true or false, then there are four possibilities. We have all four possibilities here. They can be true and true, or the first one can be true and the second one can be false, or the first one can be false and the second one can be true. First one can be false and the second one can be false. So those are all the possibilities. When you have two statements, remember each statement can only be true or false. So we've exhausted all the possibilities, and we've stated what the case about the compound statement for each of those cases. So this whole thing is called the truth table for the AND conjunction, or the AND connector, or the so-called conjunction. So you knew this already, and this is just the way it's expressed formally. So the second row of the table, that is this row here, is a short way of saying that if P is true and Q is true, then P and Q is true, and the others are similar. So only the first statement is true, only this one is true, only this one is true. So when we have TT, we have T, we have TF, we have F. So that this is the same thing as here for the AND connector, or the conjunction. Okay, so let's take a look at a data frame example of a conjunction. Well, we already did that. but let's put it in the truth table format. So we have one statement, another statement, and the conjunction. Just like before, we had one statement, another statement, and the conjunction. Here we have one statement, DF age is less than 30. Another statement, DF education equals tertiary. And what happens when they're both true? Then this is true. When one of them is false, then they're false. One of them is false, then it's false. The compound is false. When they're both false, of course, the compound statement is false. Okay, so this is just showing the same thing that we've already done in this truth table perspective. So here, why do I have that n row here? Let's go back to here. I put it n row around it. Why? Why did I do that? So let's try it. Let's run this one. What do we get? This is going to tell me how many rows are less than 30, have age less than 30. So apparently there's this many rows in our entire data set. What was the structure again? Let's do str. How many rows were there? We can get it from here. Let's just do that again. So the number of rows altogether is this many, but the number of rows where age is less than 30 is this many, just this many. Okay, let me clear that. I'll do Control L, and let's run that again, just so we have it written there. Now let's run this one. How many rows are where education equals tertiary? Or 1350. Now, the reason I did n row, and for example n row, the next one, is if we have this many that satisfy the first condition and this many that satisfy the second, then the ones that satisfy both of them are going to have to be less than this and less than this. Well, of course, if it's less than this, it's going to be less than this. Well, I should say less than or equal to. Less than or equal to this and less than or equal to this, but of course if it's less than or equal to this, of course it's less than or equal to that. But anyway, it's going to have to be less than both of these numbers, so it's going to have to be even less than or equal to this. So let's check that just to make sure. How many? Because if we get more, then something's wrong. If we get more that are both age is less than 30 and tertiary is less than education, then something's wrong. We get more than 482 because there were only 482 where age was less than 30. So I just wanted to confirm that. So let's confirm it. So there's only 135 that satisfy both of these conditions. Okay, so basically that's the story for the conjunction, or for the AND operator, So next we'll go on to the OR operator and go through the same kind of discussion, but for the OR operator. So that is here. So we're going to look at the OR operator. It's called disjunction as opposed to conjunction. And we'll also have, I'll just quickly, so the operator for that is either this one or this one, which is actually the case for the AND operator as well. That is, there are two operators. There's an ampersand and a double ampersand, and we'll talk about the difference between them. But also there's the truth table. So this is the truth table for the disjunction, not the conjunction, which is the OR operator, and this is the symbol for OR in logic, not in R, but in logic. So again, I'm trying to give you the background in computer science as well as a discussion of R. So we will come back in the next video and talk about the disjunction.